When you first launch a new software feature, everything usually snaps together perfectly. The logic is clean, the files are small, and a single developer can easily hold the entire structure in their head. But as a product grows, so do the requirements. You add new features, edge cases, and business rules. Without strict boundaries, that clean code swelling into a massive God function, where every responsibility blurs together. In this monolithic setup, the API route juggles every task at once. It reads the request, validates the inputs, checks user permissions, queries the database directly, and formats the response, all within a single block of code. This reference document lists the physical symptoms of that friction. You start seeing massive 1,000-line files, duplicate logic scattered across multiple folders, and route handlers packed with complex business rules. The system becomes so fragile that fixing a minor bug in one place can break a completely unrelated feature. And relying on AI coding agents inside this structure only accelerates the chaos. Without explicit guidance, an AI agent will simply read your tangled logic, mimic it, and quickly generate even more spaghetti code. When an architecture reaches this density, even routine maintenance becomes a risk, because no one can fully predict the side effects of a single change. To untangle this mess, developers rely on layering and separation of concerns. The concept is straightforward. Organize your code into distinct levels and give every single function, file, or component exactly one clear reason to exist. This breakdown shows common backend layers. It starts at the API layer, receiving requests and returning responses. Behind that sits the validation layer, acting as a shield to reject bad inputs. Clean inputs then pass to the service layer, the brain handling core business rules. If your product includes AI features, those require their own distinct space. Tasks like preparing context, assembling prompts, and parsing language model outputs are isolated in a dedicated workflow layer. You keep all of this complex provider logic entirely out of your standard HTTP routes. Enforcing these boundaries stops errors from cascading. A bad data format gets blocked at the surface, ensuring that raw, unvalidated network traffic never reaches your core business logic. Below the business logic, the data access layer safely handles database queries, reads, writes, and transactions independent of the UI. Similarly, the integration layer isolates external API connections. By containing third-party tools, external outages won't crash your internal logic. Finally, there's a utility layer for shared, reusable helpers, like date formatters. But you have to be disciplined here. This folder cannot become a random dumping ground for code you simply don't know where to put. Instead of a massive knot of overlapping code, your system is now a clean stack. A request drops in from the top, passes through validation, gets processed by the business logic, fetches what it needs from the database, and travels cleanly back up. Organizing your code into these predictable buckets ensures that failures are isolated and upgrades remain localized to a single distinct layer. The immediate payoff of all this organization is testability. Because your logic layers are disconnected, developers can pull a single service out of the app and test it in complete isolation without having to launch a database or load a web interface. This layered structure also acts as a strict map for your tooling. When you feed clear architectural rules to an AI coding agent, it stops hallucinating random logic and starts writing clean, layer-compliant functions. And this methodology applies just as strictly to the front end. You have to actively prevent your UI components from rendering visuals, managing state, calling APIs, and enforcing business rules, all at the exact same time. However, you must apply these rules proportionally. A tiny internal tool or a weekend prototype does not need a sprawling enterprise architecture. If splitting a simple file apart makes it harder to read, leave it intact. But as your system grows, watch out for the common traps. Avoid mixing your database queries directly with UI behavior. Stop scattering permission checks across random files. And resist the urge to create generic abstractions before you actually need them. A clear separation of concerns provides a mental map for the system, allowing teams to build, debug, and scale with absolute clarity.